Welcome to our lesson 5 on vectors form 2. Vectors form 2. I've done lesson 1, lesson 2, lesson 3, lesson 4. This is lesson 5. Is a sequence of events. Okay? Now, today we want to add to our previous knowledge on subtraction, on addition. So we are going to add something, okay? We are going to do subtraction. And I will handle both addition and subtraction. Okay? So this is lesson 5. You can see vector addition stroke subtraction. So I've merged the subtraction with addition. Vector is generally represented in a column form. Remember that. A point is in row form. A point A is 2, 5. But that 2, 5 was a movement from origin to A, described by two distinct movements. So there is a direct movement, OA. But before you get that direct movement, OA, in Cartesian plane, we saw that there are two distinct movements. So here we are. An example, this is the y-axis, this is the x-axis. So if I tell you, show me point A whose coordinates are 2, 5. That means you went this side, this you made 2, and then you went up, you made 5. That is what now I am doing. We are jogging, okay? For you to get any point, there must be two distinct movements. So the only thing I should have added there, left or right or stationary. Same thing, down, up or down or stationary. Where stationary means you have not moved left or right, neither have you moved up or down. But that is a bit of input from you, okay? Because you should be comfortable now, Form 2. You've done Cartesian plane in Form 1, eh? So even a Form 1 can follow this. It is not difficult because I'm doing it from scratch. So if I'm asked to locate point A, whose coordinates are 2, 5, being positive means right, up. So right, up. And this movement is with respect to origin. This point I've been given is A. So those are two distinct movements. Remember yesterday? If I draw a direct vector, now I write it from. You know, a vector you must tell us from to, because it's a displacement. So even these are basically displacements because they are on a straight line. From to. So this one is from O to A on a straight line, red straight line. It came about, red came about from 2 right, 5 up. Therefore, this is a right-angled triangle. I'm just joking your mind about yesterday. Suppose I ask you, what is the length OA? You remember yesterday? The length of a vector we can measure or can use Pythagoras theorem. Simple. So if this is drawn to scale, you can measure OA. Otherwise, you use Pythagoras theorem. So what would it be? 2 squared, 4. 5 squared, 25. 4 plus 25, 29. Therefore, this would be square root of 29. Do you remember? And how would it be? How will it be written? We will write OA magnitude. size of OA. That's how it is written. Then the answer would be square root of 2 squared plus 5 squared. Where do they come from? From those movements you made on Cartesian plane. That's how we get this. I hope you're okay now. Okay? Again, we remind you, suppose I have another point B, just for the sake again, B. So I have another point B, which is 7, 3. 7, 3. So look, I'll make 7 steps and I come here 3 steps. So that is my point B. Okay, that's my point B. Right. Going to B. From O to B is equal to 7, 3. That should make sense, eh? Now, I want you to think of moving from B to O. So you are at B. You are at B. Okay? You are at B. Can do it here before I come to the main work. Yeah. You are at B. Yeah. And you want to come back to O. So what will happen? If I'm here, the first movement would be left, right, or stationary. So if I'm at B, I want to come back to O using 2 movements. I'm here. I can't go right. So I have to go left. Now left, how many steps? I'll go left 7 steps. Look, I'll go left 7 steps. So you are there. You've reached here. When I reach at this point, I choose up or down. You can't go up. Okay? You can't remain there because you have not reached O. So I have to go down 3 steps. So how do I write it now, folks? I'll write BO is equal to -7, -3. Or simply, I write, and then I put, look at that. Look at that. This is the way you do it. I can take the negative outside because it's applicable to both the x coordinate and the y coordinate. I hope you get it right. And that's why we can write. Now, we can write this. Can use black, eh? If I write that is vector B. If I write OA is vector B. I can get some space here. Just some space. That's why we do this, eh? If OB is B, okay, then BO is equal to opposite. OB, the direction is that way. Okay? It is that way. So when I am coming back, see, back, return, go back, reverse, all those, the sign negative is attached to them. It is as simple as that. It makes sense. The direction has changed. Remember, we are dealing with 2 major things, size and magnitude. So if from O to A, for example, from O to A is 10 centimeter. Even if I move from B to O, it will still remain 10 centimeter. The only thing has changed is direction. Okay, so that's why we see we have changed the direction, but this remains to be the same. For example, 10. So the sign caters for direction. I hope we are right there. Okay, so now let us try to do something here. Let us do something simple here. I want us to focus now on the question down here. I want us to focus. We put now our A here, which is 2, 5. Our A, okay? Our A is 2, 5. So, from origin to point A now can be written as 2, 5, and this is called position vector. Remember, anything from origin to a given point is known as position vector. Okay? The same thing here. You can have O, B is vector 7, 3, implying OB is 7, 3. That is another position vector. Why? They come from origin. But if I asked you, maybe I put them in red. I put them in red here, and I put it here. There. So we have done that direction, and I give it vector A, and this one I give it vector B. Look. From O to B is B. From O to B is vector B. From O to A is vector A. Now, folks, I want us to learn this. I want us to learn that. AB. I want us to learn that. Okay? We want to learn how do you get A to B. Mathematically, I have many methods. If I'm at A and I want to go to B, okay, I can say from A I'll move 1, 2, 3, 4, 5. Okay, so I have 5, and then 1, 2. So I have from A to B is equal to 5, -2. That is one way. Okay, that is one way. I want us to do another way, and we see how this simple question can be handled in numerous ways. Another way is, if I'm here now, vector addition. Another way, from A to B, and these are the roads. So I'll move from A to O, and then connect from O to B. Look at that. That is really what I want us to do. Yesterday we were doing it in terms of addition, but there is an aspect of subtraction. Okay? So if OA is 2, 5, can you write AO? I want you to think a bit very fast. If O to A is 2, 5, okay, I have gone to town A. Now I want to go back. Remember, back carries Which side? Negative. But I want you to get it from here. I am at A, I'm going back to O. So what will you do if you are here? You'll do left. How many steps? 2. Then when you are here, you can't go up, you have to go down. And down still is negative. So 1, 2, 3, 4, 5. So what the process I've taken is from A, left 2 steps, then down 5 steps. So I can write. Did you get it, folks? From here, I want to come here using this road, and then I go there. Okay? We want to see if we'll get the same answer. So from here, 1, 2. Left of A by 2 steps, negative 2. Then downwards by 5 steps, negative 5. There. Okay? Then OB. OB is 7, 3. But remember, this has another way of being written. I can remove the negative and I remain with the positive inside. The opposite. You are very okay. But what do we do? What is negative 2 plus 7? A debt of 2 shillings and you have 7 bob. A debt of 2 shillings and you have 7 bob. I will pay that debt and I will remain with 5. Now here, I have a debt of 5 shillings and I have 3 bob. The debt is very big. 5 and I have only 3. So I'll pay off the 3. Still remain with a debt of 2. Okay? So folks, if you have not followed, check. This has gone through these 2 processes and we have the same answer. Okay? So I want us to look at this thing in another way. This I would have done AB is equal to negative plus OB. See? The 2, 5 is OA. Okay? The 2, 5 is OA. Now, I did the opposite. There. Okay? So, we can as well write opposite of OA. Okay? I can write opposite of OA now. So, this one becomes that is the point I want you to get now. If I put this negative outside, whatever remaining was 2, 5. And the 2, 5 represented OA. Okay? I've put the negative outside. You see, negative is out. So what remained after removing these negatives is 2 and 5. And 2 and 5 is here, which represent OA. So in short, you need to know OB. That is what I want you to get. That is what I want you to get. That whenever I get subtraction, then the first position vector is subtracted from the second position vector. See? OB, where I was going. So destination, subtract starting point. Destination, subtract starting point. This is where I was to start my journey, and this was my destination. starting point, destination. So if I give you a question, find A, B, this is destination, then subtract the starting point. So the starting point is not the origin. It is dictated by the question, like this. A, B, starting, destination. So we do destination position vector subtract starting position vector. Okay? So can I just give something here up? What I'm talking about? If P is 3, 8 and Q is -2, 4. Okay? Then I ask you, what is PQ? PQ. So what I'm saying is our destination is Q. Destination is Q. Starting point is P. So I'm saying destination position vector. Position vector of destination. Subtract position vector of starting point. Now, since this is a vector, I put it in column form. 3, 8. And then, no, not 3, 8. This is Q. So -2, 4. Okay. This is starting point. So position vector is 3, 8. So what I get is our answer. What will it be? A debt of 2 shillings and a debt of 3 shillings gives me a debt of 5 bob. I have 4 shillings and you take away 8. Okay? You take away 8. So you have a debt of 4 shillings. It's like I have 4 bob and there is a debt of 8 shillings. We remain with that. So this will be our answer. So I have demonstrated it in the diagram and I have given you how to get that. It is good that you get some questions. This is the core of future vectors. Vectors is about movements. Try to know what is happening in movement, size, and direction. The idea of equivalent vector also comes in. So can you go through this? You must have a notebook. Don't just study thinking this is a movie. No, have notes. You should know what I was trying to achieve here. I merged addition and subtraction. You can see the way subtraction comes. Just like I would tell you, 8 add -5. This. It is addition, but it has subtraction in it. In other words, I can write just 8, take away 5. See? That's why we start with addition. So addition indirectly has subtraction in it. So I have taken this version in my explanation. I want you to know from starting point to destination. When you are given starting point, the coordinates of starting point and the coordinates of destination. Okay? So I'm asked to get AB. Then I should know those points were given with respect to origin in Cartesian plane. And therefore, if I incorporate movement, which is vector, you can say from O to A is small a, from O to B is small b. Reason being, they were points on Cartesian plane, and any point must start its movement from the origin. And therefore, any movement from origin is called position vector. AB is not a position vector because A is not at the origin. But how do you get AB? You will say, from A, I'll go back to O, and from O, now I go to B. Remember what I said? From A, you go to O, from O, you go to B. So I've done it using two methods, but the second method is what will be tested more. No one will draw this. But if somebody draws now, but there is one here they drew this Cartesian plane and they gave you vector. They wanted to see if you understand the movements. Folks, have a pen, write important things, then get a book and try. Subscribe for more lessons. Bye-bye.